Okay, well, welcome. My name is Aaron Sternberg, and I am with Epic Games on the Unreal Engine partnership team.
And I'm Chris Schultz, a specialist solutions architect with AWS. And today we're going to explore technologies from both Epic Games and AWS that will help you build amazing simulation-ready 3D environments. So let's take a look at how we're going to get started here. Aaron, do you want to kick off the agenda?
Absolutely. We're going to be introducing Unreal Engine and Unreal for simulation.
And I'll be talking you through AWS Ambit, which is a tool that greatly simplifies the effort, time, and skills needed to create these 3D environments. We'll take a look at some of Ambit's features in action, and make sure you stick around to the end where we'll share lots of examples and resources that can help get you started.
And speaking of getting started, let's start this off with a pretty cool clip. Love that clip. Unreal Engine, also referred to as Unreal or UE, as you can see by the clip we just showed, is much, much more than a game engine. And some of you might be wondering, what is a game engine, or why are we even talking about it? But our goal today is to show you how it works and how it works with Amazon in the context of Ambit. So first, let's define game engine. And Wikipedia actually has a pretty good definition. I mean, we believe everything on the internet we read, right? But in all seriousness, in a nutshell, a game engine is a development platform. And sometimes when people think game engine, they think beautiful pixels, beautiful games, but it's much more than that. It's an environment, an entire environment to facilitate faster development. And development of games, of course, but much more, like complex workflows. And Unreal Engine 5 is actually the right tool to simplify those complex workflows. I'm going to read this actually word for word because it's perfect. Unreal Engine 5 enables game developers and creators across industries to realize next generation, real-time 3D content and experiences with greater freedom, fidelity, and flexibility than ever before. And simulation is in one of those industries. In fact, across all the different fields we work in, we have a million or more, millions actually, of global licensees producing super interesting products, applications, and experiences. Now, on top of simplifying complex workflows, we've actually solved the complexity of reconciling real-time data accuracy with photorealism. And to illustrate that point, I want to share a story with you that a friend of mine shared with me, Seb Lozé. He's our simulations industry director. Once upon a time, in a beautiful country far, far away, there were two brothers, two princes of a same kingdom, the Realtime kingdom. And in this magnificent real-time kingdom, these two brothers, one was beautiful and charming, while the other one was very smart and accurate at everything he said and did. Unfortunately, these brothers were at war because the smart brother, although very smart, could not understand how the beautiful brother was so beautiful. And the beautiful brother could not understand why the smart one was so smart. And of course, couldn't get along in this real-time kingdom. In fact, real-time accuracy and photorealism could not work hand in hand together. And in this world, that has been the case over the last 25 years, where simulation builders have building simulation applications, wanting to make sure that everything they train their people on was precise and accurate, true to life, based on the laws of physics. Now, and because of that, and because of the technology of wanting to run real time was not available, they had to contend with poor graphics and environments that were not visually appealing, thereby lowering the level of engagement of their trainees. So fast forward to today, we realized that the world of gaming and the world of simulation can coexist. Hardware technology provided by NVIDIA, AMD, and Intel and other graphic cards producers, along with the deployment capabilities brought to us by the fantastic teams at Amazon Web Services, is really allowing anybody to benefit from this high-end technology. So effectively, it makes it possible when you optimize your algorithm for you to reconcile real-time accuracy with photorealism. And this is what we're doing with UE. We are not the builders of simulations. Those would be our customers, our users, our people who are actually working in Unreal Engine and developing and using it as a development platform. In our case, the sim domain goes from healthcare to space exploration, passing by civil aviation and defense. And you can see all the wonderful things that our creators are making on the screen above. Now, there have been many features and performance improvements to empower you to create a bigger, more visually, more stunning simulation application. And with Unreal Engine, we're here to help creators produce detailed 3D environments and immersive experiences without requiring an even bigger team. So let's talk about some of the features. The first one is called Lumen, and it's really linked to photorealism, the beautiful brother. Some of you might already know with photography that photography means literally writing or drawing with light. And that's what we're doing with UE5. We're making sure that the light is writing or drawing correctly into virtual scenes. Now, it might seem like an obvious thing to do with a game engine. In our case, though, we realize that traditional game engines and systems of 3D rendering were not following the light entirely, just capturing a couple bounces of light when the light was reflecting on objects. But light doesn't stop reflecting. Lumen is a UE5 module that makes sure that light never stops bouncing. So to your eyes, what it is showing you is an environment where the light looks real because it's literally doing what light does in real life. And it can only do that if light is bouncing on surfaces that are well defined. In fact, we had to make sure that all the surfaces where the rays of light were bouncing on were the most detailed as possible. Which brings us to the next feature called Nanite. Nanite is a new virtualized micropolygon geometry system. What does that really mean, though? Essentially, you can directly import the highest quality source art comprised of millions of polygons, place them millions of times while maintaining the real-time frame rate without any noticeable loss of fidelity. This is done by intelligently streaming and processing only the details you can perceive. These polygons are of the highest definition and quality. Again, the same type of quality definition needed for Lumen light bouncing. So you have light, you have visual fidelity down to the micropolygon. And you might be thinking, what if I need to draw the world? What if I need to create an environment that is encompassing the entire planet? How do I do that? How do I deal with that? Well, historically, game engines were known to be super good and super fast in small environments. But UE5, we can start talking about large environments. We can talk about world partition. Now, the world partition system is part of a global activity we have at Epic Games. We're making sure that the sky is not the limit when it comes to building simulation applications with Unreal. And what we mean by that is that we're solving several problems. One of them being the problem of math. When an object goes very, very far and very, very fast from point A to point B, the further it travels from its point of origin, the more inaccurate the calculations of its trajectory. Traditional game engines, cutting corners, trying to simplify things, operating on a 32-bit precision when moving objects. But what we did in UE5 is we reworked and optimized entirely on mathematical calculations of object trajectories, geo-coordinates, object movement, and their internal structural physics. So going from 32 to 64-bit precision to some of you might seem inconsequential. But imagine if you're doing the same math with the same numbers and those numbers aren't truncated, well, any errors you might introduce would be extremely small. You could fly from Earth to Pluto with less than a centimeter of a margin of error. Pretty practical when building simulations. The smart brother, am I right? World partition is helping users to sort out that complex puzzle of, now that I have a large world, how do I implement it in a way that's easy? In fact, in a way that's easy to connect with other large worlds. So to prove this feature out and others, we created City Sample for users and creators to dive into and experience firsthand. Again, slide has perfect words. I'm going to read it. The City Sample is a free downloadable sample project that reveals how the city scene from The Matrix Awakens, an Unreal Engine 5 experience, was built. The project, which consists of a complete city with buildings, vehicles, and crowds of metahuman characters, demonstrates how new and improved systems in Unreal Engine 5 were used to create the experience. You can actually download the City Sample for free on our Unreal Marketplace, and we'll show you how to do that a little bit later. Let's talk about Unreal Engine for simulation. And when it comes to simulation, in detail, there are a lot of other mobile modules that are important for developers. And simulation can be a simple process. First, create your content, have the scenarios executed, then you have trainees or analysts have interactions with these systems. And all simulations are leveraging this type of process. And for each element of this process, we have a solution. So if you allow me, I'm going to go over every little box in this slide. Okay, I'm just joking. But here, the slide is here really to show you the breadth and depth of our ecosystem, where each line is a module of UE or a product from our ecosystem that is allowing developers of simulators to have all the right tools available and the right ecosystem. All these modules that we're putting together, the chart you just saw, is just the framework. It's just the development environment. We're not simulation builders at Epic Games. We are providers of the right game engine to allow you to integrate into that framework, to integrate your creations, to build the pyramid that is the simulator. And on top of that, creators are integrating solutions together, focusing on this level 3 effort by making sure the entire ecosystem provides modules that are already pre-integrated with UE. All your team has to do is to define what the right elements of the puzzle you put together. Make sure you develop that special feature the way you need them for your use cases. On top of that, add your curriculum, add your data set that you want to train or analyze or run any simulations on. We are here to support you. Flash forward to the kingdom today of Realtime. Those two princes, well, they're ruling together in peace. Now I'm going to pass this over to Chris. He's going to share with you how AWS customers can use Unreal Engine on AWS for simulation projects. Chris?
Great. Thank you, Aaron. So Aaron has shown you how Unreal Engine itself provides a really powerful foundation for simulation, an engine that's capable of amazing reproduction of light, incredibly detailed geometry in the environment, and the mathematical precision and performance you need to simulate really large-scale worlds. But you need two more things when you're going to apply simulation. You need an actual simulator. That simulator will be in charge of running the different scenarios, running the test conditions that you want to test your systems against. And you also need the 3D content, the 3D environment within those situations in which those simulations will run. So you can think of that as sort of your sandbox for your simulations, right? So that's where we come in. We have customers at AWS who use all sorts of simulators. Many of those simulators are based on Unreal Engine as the underlying foundation. Some are based on other technologies. And some of these simulators are open source, such as the Carla simulator or AirSim. Some are from other vendors like Ansys and Applied Innovation and NVIDIA and others. So we talked to these customers who are already using simulation on AWS and asked them what they were still struggling with in applying simulation to their use cases. And a common theme we got was that the content creation piece, building those 3D environments, was a real struggle. This is because it often takes specialized 3D design skills that our customers don't necessarily have in-house. It can sometimes require expensive and difficult to learn 3D software packages. But most of all, it just takes a lot of time and effort to build these 3D environments, especially since you want broad and varied environments to really present a robust challenge to the system that you're testing. So we took it upon ourselves to invent a way to simplify this task of content creation. And the result is AWS Ambit Scenario Designer for Unreal Engine. AWS Ambit is an open source plugin that we've developed for Unreal Engine that greatly reduces the time, effort, and specialized skills you need to build these 3D environments, all while still letting you use your preferred simulator. So it's best to understand the value of Ambit by thinking through a real-world example of where you might use it. So let's take an example where we're developing some perception algorithms and some control logic for an autonomous vehicle system. And we want to use simulation to be able to test and validate that our implementation can safely navigate a vehicle through a construction zone like the one you see here. Now, the simulator is responsible for running your logic that does the perception and drives the actual hero vehicle through the environment. But you still need one important thing, and that's the environment. So we need to create or build this construction zone. But ideally, you want more than just a single one. You want 10 or 100 different variations of what a construction zone might look like in the real world so that you're really presenting a robust test. That's where Ambit really shines. So we're going to take a look at this example and build a construction zone, and you'll see how some of the tools apply to this scenario. But let's start by setting the stage with some terminology I'll be using. So I'm going to talk about the 3D world. You can think of the world as anything that's stationary and non-moving from one simulation to the next. So this will be things like the buildings and the roadways in your simulator. This is the context in which all your different test scenarios will be run. Now, within an individual test scenario, you'll have static obstacles. These are the things that won't necessarily move while the simulation's running, unless perhaps they're hit by something. But they may change position or appearance based on the specific scenario you're trying to test. Dynamic obstacles are any of those objects in the world that are moving during the time of the simulation. So think of things like pedestrians and cyclists and cars. And then we also have environmental effects. So that would be things like the time of day, the visibility conditions, the weather conditions for that particular scenario. If you combine these three elements, the static obstacles, dynamic obstacles, and environment, if you take one particular configuration of those three, that's what we call a single simulation scenario. And in Ambit, you save these scenarios out as simple text configuration files that can be loaded into a simulator at runtime. So now that we've got some terminology set, let's start using the tools. And I'm going to start by leveraging some static obstacles that will comprise this construction zone that we're building. So what you see here is the standard Unreal Engine interface, but I've already installed the Ambit plugin, so I get a few additional items in the UI. Over in the Actors tab, I get a special tab for AWS Ambit. And the things you see here are some of the common tools you'll be using a lot in Ambit. In Unreal Engine terminology, an actor is really just a reusable element that you can add to any 3D environment. We also provide a special Ambit mode that you can put the editor in. And this reveals a panel that lets you control some of the global settings for a scenario. And we'll dig into that a little more deeply in a moment. So let's start building our intersection, our construction zone. To start, I'm just going to position my camera in a convenient location. And we'll start by laying out that path of traffic cones that are going to get traffic to merge into a single lane. So for that, I'm going to use the Spawn on Path tool. We just add it to our map where we want our path to begin, and we just draw. We use the built-in spline tools in Unreal Engine to draw a curve that will represent where we want those cones to be placed. So I'm in overhead view to make it a little easy for myself. When I have the shape I want, I can switch back to my original perspective. And now we just have to set some settings on this tool to control its behavior. So those settings are found in the Details panel, which you see on the right. I'll scroll down to the Ambit Spawner section, and you'll see a whole bunch of different parameters we can use to control the behavior of that tool. So I'm going to start by telling it exactly what type of item I want to be placed along that path. In this case, it's just going to be a simple traffic cone prop. And then I need to set a density. So this is presented as a range, but I'm going to use the value 3 for both the low end and the high end. This just means I want those traffic cones to be placed at an average of 3 cones per meter. And finally, we'll turn on the snap to surface feature. This is great for when you're trying to place things on uneven ground because it will assure that the elements always sit well on the ground. So now let's preview our scene, and you'll see right away it took care of laying out all of those cones for us. But where the real power of Ambit comes in addition to making things like this easy, is making it easy to generate many different variations of the same common setup. So we do that by adjusting the random seed value, which is a deterministic value which will always result in the same random variation. So by entering a new value, I can create unlimited different variations of that particular tool. So let's make it a little more interesting by adding not just a single type of traffic cone, but multiple types. So I just add an additional slot for the types of things that should get created, and I drag in a new element, and now you see it provides me with a variety to the elements that get created. And again, the random seed tool will let me play with different variations. So I'm going to quickly use that same tool again to create a row of barriers on the other side of the street. And this will give me an opportunity to show you one more feature of this particular tool. So I'm going to use very similar settings. I'm just picking a barricade element here, same density and same snap to ground. But when we preview, you'll notice all the barriers, they aren't lined up. They're just kind of scattered everywhere. That's obviously not what we want. So we can address that by using the rotation limiting feature of this particular tool. So I can set a minimum and maximum bounds. I'm going to use 85 and 95 degrees as my min and max. And now we get a nice, more or less straight row with just a little bit of subtle variation to it. And of course, we can randomize that as well to create many different variations. So the next tool I want to show you we call Spawn in Volume, and this just lets you place a 3D volume, a box, in your environment within which items can be placed. So this will be very handy for us to create that sort of staging area in our construction zone where all of that construction material gets placed. So I'm going to set a width and a depth bounds here. We don't need any height to it for this particular example. And I want a lot of different items in this section. So I'm just going to add a bunch of different slots for things that can get created and added to our scene. And with those added, this time I am going to use the range for my density. I'm going to set a pretty wide range, and you'll see why that's useful in just a moment. Finally, we'll enable that snap to surface feature again. And when we preview this, now you see all these construction materials sort of spawn into that location. And because we've used a wide range, when we generate the different variations, it's always going to pick a different value within that range, which can give us very sparsely or very densely packed variations and some very sparsely packed ones. You can also use this same tool in creative ways. So I'm going to use that tool now to place a single item, a road closed sign, within our scene. This time I'm just setting it to a very tight bounding box. I'm going to add the road closed geometry that I want. And again, use that min and max angle to position it so it's always generally facing the same way. And I'll set the density to exactly 1. Now when we preview this tool, we get that single road closed sign, but the variations all put it in a slightly different position, but in the same general area. So that's a little bit about the static obstacle tools. Let's take a look next at dynamic obstacles. So in your simulations, you are always in control of the hero vehicle, right? The vehicle under test. That is, your implementation is going to drive how that thing navigates through the environment. But it's often, in addition to having these static obstacles that vehicle may encounter, it's often advantageous to have sort of adversarial vehicles that it has to contend with. So we wanted to make it really easy to create scripted sort of traffic scenarios, and that's where the vehicle path tool comes in. So we're going to drop the vehicle path tool into our scene to add just a single vehicle that will drive through that our hero vehicle has to contend with. And we'll draw the path such that this vehicle merges and then passes on through the intersection. So a very simple example, but you can see sort of how easy it is to script this vehicle motion here. We just need to tell it what vehicle we want to use in this scenario. And we've designed this to be compatible with any vehicle that adheres to Unreal Engine's standard vehicle rig. What this means in practice is you can find all sorts of options of vehicles to use in your scenarios from the Unreal Engine marketplace. So I'm going to use a free vehicle pack that I downloaded from the marketplace and choose one vehicle from that pack, this blue hatchback here. So we've chosen the vehicle. Now I'm going to give it a speed limit that I want it to try and maintain through this path. And now when we preview, we get the vehicle, it does the merge, and then continues on through the intersection. So it was super easy to set up, and we could add more and more vehicles to create more and more complex scenarios. For example, a vehicle running through a stop sign or a vehicle pulling out from a parking spot on the curb. All very easy to do. Next, let's take a look at environmental effects. So a lot of simulators provide their own environmental system. We wanted to provide one that you could use as a drop-in in any simulator. And it also provides a way, even if you are going to use the environment system in another simulator, to sort of preview what the settings will look like when the simulation is running. So to use this, it's found in the Ambit content folder under environment effects. And we're just going to drag our environmental effects component into our scene. And I just need to delete the default sky that I had in there before adding this thing. So to control these weather effects, that's all done through the scenario mode panel that I mentioned before. So this controls global settings for your scenarios. We provide some easy presets you can use. So for example, if I want to set the time of day, I can choose from the time of day preset menu here. So we'll choose a morning preset as just an example. But you have complete control. So we also provide a slider where you can dial in the exact time of day that you want to use in your scenario. So we'll set it to roughly a midday time for the rest of the demo. We have some weather presets as well. So here's foggy. Here's a rainy preset. But those presets are made up of individual parameters that you have complete control over. So I can completely customize the weather conditions. So for now, I'm going to start by making it an overcast day by dialing up the amount of cloudiness. I'm going to dial up the wetness of the roadways here. And as I make it wetter, you'll start to see reflections appear in the surface of the road. And then we can also add some puddling that occurs. So those are some of the weather controls you have. There are two additional global values you can set for your scenarios. One is pedestrian density and vehicle density. Now you won't see these reflected in the live preview in the editor here. That's because these values are used to feed simulators that have their own pedestrian and vehicle systems. So these values will be used in those cases. Okay, so we've set up our scenario with our static obstacles, dynamic obstacles, and our weather conditions. Now we can save that out. Saving out an individual scenario is super easy. We just use the export scenario button here, and it will save a local copy of that scenario. It's really just a JSON file. We call it a scenario definition file. And it's meant to be easily ingested into any simulation system. So you can see here, it's a pretty simple file to understand. It has all the time of day and weather settings that we entered. You see that pedestrian and vehicle density value. And then you see the result of all the dynamically generated content within that scene as well, including its position and rotation within the world. And our vehicle path is described here as well. So hopefully you've seen how easy this makes it to create individual scenarios and sort of explore with that permutation generation. But we wanted to go a step further. We don't want you to have to create each individual scenario by hand. We want to automate the process of creating many different variations of a particular scenario. So that's where our bulk generation capability comes in. That's also found in this same panel here. To start, I'm just going to tell it where I want to save the output of this. It's going to save to an S3 bucket in my AWS account. And then I opt into the permutation space that I want to explore. So in this case, I'll choose two different times of day, two different sets of weather conditions, and then I'm going to set ranges for the pedestrian and the vehicle density. Once we've entered this particular description of the permutations, you'll see it calculates that it's going to have to generate 72 unique scenarios to completely cover that simulation space, that exploration space. So I'm going to give that, I'm happy with that. I'm going to give my configuration a meaningful name. And then I can also optionally assign a prefix, which will be added to the files to help me find them more easily. And when I hit the Generate Permutations button, it generates all of those variations and uploads them automatically in the background to S3. So we see a configuration file. If I ever want to go back and tweak this bulk configuration, I can. But then we also see a folder containing each individual generated scenario, ready to be imported or loaded into a simulator. Let's talk about the world in general. We talked a lot about the individual scenarios, but let's talk about that global sandbox. So the example I've shown you so far used assets I downloaded for free from the Unreal Engine Marketplace, which is a fantastic resource. The city that I had as the basis for that example was created by some talented artist somewhere. But we don't want you to just be limited to content that other people have created. We want to empower you, even if you're not a 3D modeler, to be able to create your own unique environments. So with Ambit, we provide a way that you can generate a city from OpenStreetMap data. So here I am on the OpenStreetMap website. I'm just going to zoom in to a section of Seattle near where I live. And I'm going to pick a section of that map to export and use as the foundation for my 3D world. So I'll just save this exported file to my desktop for easy access. And then when I go over into Unreal Engine, I can use one of the procedural tools we provide called the Ambit Building Generator. We have Ambit Building Generator and Ambit Road Generator. I'll place the building generator into an empty map, an empty world. It will do a little bit of initialization, and then I'm able to access a bunch of different configuration properties. But really, many of these are optional. The only one that's required is I just have to point it to that OSM file that I downloaded. So we load up that file, and it goes through a process called cooking, where it's analyzing that file and its metadata and generating the 3D buildings that represent that real neighborhood. So it doesn't try to recreate the facades of those buildings, but what it does do is it matches the real footprint in the real world of those buildings, the real height of those buildings, and of course the placement. And it uses some of the metadata about those buildings to provide some visual variation as well that's realistic. So in addition to the buildings, we also need the roadways, right? So we provide that as a separate tool because there are many times where you'll have a simulation and you only need the roadways. You don't care about the buildings. But we'll add the roadway tool to our map now. And we'll just point that to the same OSM file, the OpenStreetMap file that we downloaded previously. So here we are. Here we have the complete road network for that particular neighborhood ready to run in simulation. Here are just a few examples of the types of output you can expect from the Ambit Building Generator, just to give you a sense what feeding different areas into it will result with. We've intentionally chosen sort of a simplistic visual aesthetic here. We're really anxious to hear from you what sorts of visual fidelity and visual detail is important to your simulations so that we can consider adding that to Ambit as well. So that's just scratching the surface. Those are some of the key features of Ambit. There's many more features I won't be able to demo today, including a way to spawn items based on metadata in your scene on different surfaces. We provide a way to create actual procedural obstacles themselves, where the obstacles may change their own appearance procedurally, and we provide an example asset that shows you how to build that kind of obstacle. And then, of course, you can export the content you create for use in other 3D tools, even beyond Unreal Engine. So hopefully what you've seen here has gotten you excited about these tools, excited about the technology and the possibilities. We wanted to make sure it was easy for you to get started, so we want to walk you through a few resources you can use.
Well, first, you can go to unrealengine.com and download the latest version of Unreal Engine. The second QR code really is about working with virtual workstations on the Amazon Marketplace, and that URL will bring you to an opportunity to access either an Unreal Engine 4 AMI or an Unreal Engine 5 AMI. And then, of course, the QR code I talked about earlier, where you can download City Sample. And then finally, it's a simulation blog post that I wanted to share with you guys.
And on the Ambit side, it's very easy to get started with Ambit. We just launched on the Unreal Engine Marketplace, so now you can get the plugin directly from the Marketplace, which is fantastic. You can also join us at GitHub. We want to hear your feedback. We're there to help you as you learn these tools. The examples I showed you today showed Ambit in the context of Unreal Engine 4, because that's what a lot of the simulators are still based on. But as these simulators start migrating to Unreal Engine 5, we want to hear from you what Unreal Engine 5 specific features you'd like to see Ambit take advantage of. So you can do that by letting us know on our GitHub page. Thank you so much for your time, and we can't wait to see what you build with Unreal Engine and AWS Ambit.
Thank you.